these are two examples of really hard GCSE grade 9 vector questions that we are going to look at. Now, both of these questions are very similar in the sense that they're both vector questions and they also use ratios, as you can see here. So with that, as you all know, ratios throws up all sorts of challenges, which we are going to look at. So let's start off with the first question right here. Okay, this question is in two parts. You've got a part A and you've got a part B. And part A is pretty much straightforward. Let's go and read the question and mark in on the diagram anything that we find useful. So you can see here that this is a quadrilateral. So CDEF is a quadrilateral. It says from C to D, so that means from there to there, it is equal to A. And from D to E, right there, is equal to B. And F to C is equal to A minus B. So what we're going to do very quickly is write those in. So let's start off with C to D. So C to D, we are told is A. And D to E, we are told is B. Now, because M here, if you read the next part of the question, it says M is the midpoint. We don't have to worry about it now. But what I will do is rather than write the B on the line D to E, I'm just going to write it on the outside like that. Okay. And F to C, so that means F to C this way, going this way, is A minus B. So we can write that in here like this, A minus B. Okay, so the question says that we need to find FE. We need to find FE and express it in terms of A and or B, giving our answer in its simplest form. All right, so if we write down FE like this, let's trace where F to E is. So here's F and here's E. I want to go from there to there. Now, there's no direct route. I can only use anywhere where I've drawn the arrows. So those, I can use all of that. But there is no direct route that takes me from there to there. So which way can I go? I can go across this way, which I don't really want to at this stage because, again, there's no route here that is written down. But I can go from F to C, C to D, and then D to E. Okay, so what I'm going to do is I'm going to go F to C. I'm going to add on C to D, and I'm just tracing out the route here because it helps a lot of students understand what they are doing. And the final one was D to E, from there to there. So D to E. All right, so let's go and write down those vectors. So F to C, we are told F to C is A minus B. So what do we write underneath that? We write A minus B. And then we're told that C to D is A, so we can write plus A. And D to E, we are told is B, so we can write plus B. So that's what we have. Now we can just simplify this, which means to collect the like terms. So we've got an A here, and we've got another A here, giving us 2A. So let's write that down, 2A. And the B, we've got minus B plus a B, so they cancel out. They would cancel out, and we're just left with 2A. So 2A is our final answer for the vector F to E. All right, let's go and read the next part of the question, which is when it gets a lot more complicated. We are told that M is the midpoint of D to E, as I mentioned earlier. So let's write down what that means for us. It means that from D to M is going to be half of B. So we can write down here like this, a half B. And of course, this is also going to be a half B as well because M divides D to E exactly in two parts. So it's a half here and a half there. Okay, so let's continue reading the question. It says X is the point on FM such that F to X and X to M is in the ratio N to 1. All right, so let's highlight where FM is. So this is the line F to M. And we are told that it's been divided up into the ratio F to X is equal to N, which we don't know what it is exactly. And X to M is equal to 1. So let's write that down. F to X is N and X to M is 1. Okay. So it says that CXE is a straight line and CXE is from there to there. So let's draw a straight line in there. So let me do that. Going through X. There's our straight line. Okay, we'll see how we can use that in a bit. And it's asking us to find the value of N. So where do we begin? A lot of you might look at this question and think, how do I start this? Well, if we look at the ratio, we are trying to find the value of N. That's what we've been asked to do. And N here is representing F of X. F of X. So let's find the F of X vector. And we have to do this by finding it in two different ways. so that we can have a simultaneous equation and find this unknown. I'll show you what I mean by this. Let's start off by tracing one of the roots for f of x. Okay, now remember, I can't go from f of x directly there yet, but what I can do is I can say that to go from f to x, so let's write this down actually. So f to x, this is one of the roots. We can say that it's n parts out of the total, which is n plus 1. Okay, so it's this much of the total fm. So we can say it's n over n plus 1, because n plus 1, we're adding them together to give us a full value of that line f of m. And it's the part of f of m. Okay, so just to reiterate what I've just done is f of x, so f to x is n out of n plus 1 parts of fm, which is the full line. Okay, so that's one way we can write that. Now, obviously, we're going to need to calculate f of m at some point, which we will do very shortly. But let's write down another root for f of x. Okay, you can do this now or you can do it later. It doesn't actually matter. You can actually go ahead and find f of m if you want to. Okay, but let's also write down another root for f of x, because that's what I started off by saying we will do. So what is the other root that I can take to find f of x? Well, I can go from f to c, and I can go from c to d and d to m and then go backwards. However, a quicker way and probably a more simpler way, and using this information that it's given us about the straight line, we can go f to c and then we can go down c to x. Now you may be wondering, we don't know anything about c to x, but we will write something down here. Okay, let's just write down that root first. So we're going to do f to c plus c to x. So now the question arises, we know what fc is, which is a minus b, f to c, but we don't know what c to x is. However, if we write down a value here, we don't know what part of this is, we don't know the ratio that it's been divided up into. And because we don't know the ratio that it's been divided into, we can give this a letter, an unknown. A classic unknown that people like to use, mathematicians like to use, is lambda, the symbol lambda. But I'll make it more simple. I'll add an x, okay? This is x part, okay, out of the total parts, okay? An x portion of it, a portion of it, okay? We don't need to know the exact full length either, by the way, okay? But this x is a portion of that full line, okay? So what we can say here is x parts of c to e, the vector c to e, okay? So c to x is a part, x parts of the full vector c to e. And that's what this is there for, okay? All right, so let's go ahead, go back to this and find what f of m is, okay? So f to m, let's go and look at the diagram again. So f to m, we're going to go from here to here, remember, is going to be fc, cd, and dm, okay? So it's going to be adding this, and adding this, okay? Now because we're running out of space, I'm not going to do this part of it that I did for the others, okay? I'm just going to add these along, okay? So what do I have? I have a minus b plus a plus a half b, okay? So I've just added this, and that. And I've got from f to m using that rule. Let's collect all the like terms here. So what do we have? We have an a plus an a, so we have 2a. And we have minus b plus a half b. So minus 1 plus a half, which is minus 1 over 2b. And this is your fm. Let's put a box around that so we can use that for later. And of course, this will now go right here to replace this. So let's go ahead and do that. So let's move down a little bit here. So f of x is equal to n over n plus 1. And in brackets, we are going to insert this right there. Okay, so that will be 2a minus a half b. Now, we are going to expand this out. Okay, we're going to multiply this with that. We're going to multiply this with that. So what's that going to look like? That's going to be n over n plus 1 in brackets 2a minus n over n plus 1 in brackets, oops, not that way, a half b. Now, what we can also do is get this 2 involved with this fraction and this half involved with this fraction. Now, this 2, while it's involved with this fraction, will just multiply with the n at the top. So what will that give us? That will give us 2n over n plus 1 in a bracket and the a outside. So I didn't multiply the a with it, just the 2 with the top, the numerator. I'll do the same thing here. Now with this one, the 1 will multiply with the n, just giving us n, and the 2 will multiply with these two at the bottom. Okay, so the 2 will multiply with the n plus 1. So what will that give us? It will be a minus, and then it will be n over 2n plus 2. Right, so this is fx, okay, the vector fx. And let's put a border around that. Let's go back to this one again. So we are looking for CE. Remember, both of these are f of x. We are finding two different ways of getting f of x. So now we're going to find CE. All right, so let's find CE. Let's do that here. So CE, the vector CE, we're going to need to look at the diagram again. So C to E, C to E. How do you get there? Well, obviously, we're not going to use this route here, but we can get there by going from C to D and then D to E. Okay, so what am I going to be doing? I'm going to be adding the A and the B together. So A plus B. So C to E is A plus B. And there I could put right there. Okay, so let's go ahead and do that. So we've got the A minus B from before plus a part of C to E. For the part, we are using X. You could use any letter. You could use lambda. You can use alpha, whatever you want. But I'm just choosing to use X to make it simple, as I said before. So part of A plus B, which is C to E. Let's collect all the like terms now. So what do we have? Let's expand that out. So A minus B plus AX plus BX. Now I'm going to move this down a little bit because this is going to get in the way. Let's just move that down here. So what do we have? How many A's do we have? Now we can't actually collect them together, but what we can do is collect them and then factorize the A out. Okay. So I'm just, before I do that, some of you may get stuck on this step, so I'm going to break it down for you. So this is what I'm doing, plus bx minus b. I've just put these two together. Okay. I'll put that positive though, and I've put those two together right there. Okay. I'm going to take out the A now. So I'll have 1 plus x A plus x minus 1 b. Okay, just in case you're wondering, what I've done here is I've factorized out the common factors. So the common factor here is A. So A and A comes outside the bracket. You may be used to that being here. Okay, I've just put it there. It's the same thing because they're multiplying. Okay, and that's what I've done for both of them. Okay, so this is fx. We've done all the hard work now. Now comes comparison. Okay, so if you compare both of your f of x, let's put a border around this one as well. If you compare, this is one version and this is the other version. Both of them have an a right there and they have a b right there. They are both equal to each other because they are the same root, f of x, right? So therefore, what we can do is just say, look, this coefficient in front of a is equal to this coefficient in front of a. And this coefficient in front of b is equal to this coefficient in front of b. Okay? With that, we can then write that 1 plus x is equal to 2n over n plus 1. And we can also write for the b, comparing to that, we can write x minus 1 is equal to minus n over 2n plus 2. Now, all we have to do is make the x's equal to each other because both of them have x's. So we're going to make x the subject here and x the subject here. So in order to make x the subject here, we're going to have to get rid of this 1. So we can take this 1 to the other side. So we're going to have x is equal to 2n over n plus 1 minus 1. And on the other one, we're going to take the minus 1 over to this side. So it's going to become a positive. We're going to have x is equal to 1 minus n over 2n plus 2. Now that we have them both as x's, we can equate the two. We can make this equal to that. So that would be 2n over n plus 1 minus 1 is equal to 1 minus n over 2n plus 2. And we just have to solve this. So we can solve this in whichever step you want to take first. It's totally up to you. You could choose to take the 1 onto this side, or the other way around is completely fine, or you can multiply by n plus 1. If you multiply by n plus 1, for example, you're going to have to multiply this by n plus 1, this by n plus 1, and this one by n plus 1 as well, which probably means that this should have actually been left in an unfactorized state. So let's quickly do that. Let's put that back into the unfactorized state. In fact, not the unfactorized state, the factorized stage. Sorry about that. So n plus 1. Okay, there you go. So let's multiply by n plus 1, everything by n plus 1. Okay, so we're going to multiply by n plus 1. So that would mean we're going to get rid of this. So that's going to be just 2n. This will become minus 1 and then your n plus 1. So it's going to be just that. This 1 will just be n plus 1. And then here with the n, you're going to multiply the n plus 1. And on the bottom, you'll still have the n plus 1 there. Now, do you see why we put it back into the factorized state? Because now, look, these two can cancel out directly like that, leaving us with just n over 2 here. Okay, so we can have 2n minus n minus 1. So all I've done is I've just expanded that out with the negative sign outside. That's why this is a negative. And then this would be n plus 1. And I said that these two will cancel. Okay, so that just leaves me with minus n over 2. Now I want to get rid of this 2. What do? I'll multiply by 2. Okay, everything by 2. So this 2 will multiply this by 2, this by 2, this by 2, this by 2, and this by 2 as well. But before you do that, you can collect like terms. Okay, so we can collect those like terms here. So that's 2n minus n, which is 1n minus 1 on this side. And here we'll just leave that as it is. And let's now multiply by 2. So this will become 2n minus 2 is equal to 2n plus 2 minus n. Again, let's collect the like terms. So we've got 2n minus n here. So we'll have 2n minus 2 is equal to 1n plus 2. Let's now take this n over to this side. So that will be n here. And then minus 2 is equal to 2. Let's now get rid of the minus 2 on this side. Take it to the other side. And then n is equal to 4. So your answer for n is equal to 4. Let's go back to that diagram. See what that was. It's right here. So this is equal to 4. So in total, f to x is 5 parts. Okay, so the next question here, you could perhaps try this yourself. Press pause here on the video, and then do your own solutions. And when you're ready to go through it, then press play, and then you could follow step by step what I did. All right, so this question, OAB is a triangle. So obviously that's a triangle here. It says OPM and APN are straight lines. So OPM is a straight line and APN is a straight line. And we're told that M is the midpoint of A to B. It says O to A is equal to A, the vector O to B is equal to B. So let's put those in. So O to A here is A, and O to B here, again on the outside, I'm going to put that B there, right there. Okay, and we are told that O to P and P to M is in the ratio 3 to 2. So O to P and P to M is in the ratio 3 to 2. So 3 and 2 right there. Work out the ratio O to N and N to B. Okay, so how do we do this question? Let's look at the ratio. That's the clue. The clue is always in the ratio, like in the previous question. So O to P here, we're told is 3 parts. Let's find 2 ways of finding O to P. Okay, just like before. So O to P, let's mark it out. Okay, how do we get from O to P? Well, obviously we're not going to go this way, but we can put down a value for this. Okay, we know that it's 3 out of the 5 parts. Okay, it's 3 out of the 5 parts of what? O to M. So 3 out of 5 parts of O to M. Okay, and again, we're going to need to find O to M separately. We can go O to A, and we know that A to M is half of A to B. Why? Because we're told that M is the midpoint. So let's write that down for now. Okay, so we're going to go O to A plus a half of A to B, which is A to M. Okay, What is now A to B? Okay, we're going to need to find A to B. So A to B. So we can go backwards to O and then forwards to B. Okay, so we're going to use A plus B. So A to B is minus A plus B. And we can write this as B minus A instead. So that's A to B. Let's put a box around that. And that will go right there for A to B. Okay, so that will be O to M is equal to O to A, which we know is A, plus a half of B minus A. Okay, all right. Hopefully, so far so good. That's O to M. We can now put O to M. After expanding this bracket part out, we can put it right in here again. So if we expand this O to M out, sorry, it's a little bit squashy in here. So A plus a half B minus a half A, which simplifies to, let me just go down here, which simplifies to collect both A's together. So A here and minus A here. So that's 1 half A plus 1 half B. And that's my O to M, which is going to go right here. So therefore, O to P is going to be equal to 3/5 of O to M, which is a half A plus a half B. And again, you can expand this out 3 times 1 and 5 times 2 when you expand that one out. And likewise, 3 times 1 and 5 times 2 for that one, giving us 3 over 10A plus 3 over 10B. And that is O to P. So that's one way that we can get from O to P. We just have to find another way to do the same thing. Well, we went this way earlier using the part of a O to M. This time, let's go up here and then down here. Okay, so once again, you need to know what part this is. Again, you don't know a particular part. So once again, you could use a letter to represent a part. So let's use the letter X here, just like before. Okay, so we're going to go O to A and then A to P. All right, so O to P, another way to get there is to go A plus X part of A to N, right? Now, again, we need to find A to N here. So what is A to N? Let's just write this down here. And the root that we're going to use is A to O and then O to N. Now, once again, we don't know the part of O to N, how many parts this is. So we're going to use another letter here to represent that. And this might start to sound very confusing for many of you, but just bear with me. And if you need to rewind, go back and rewind, okay? So Y here would represent a part of the full O to B, which we know is B, okay? So once again, A to N, we're going to go minus A plus Y part of B, okay? So that's going to be minus A plus Y part of B. All right, so we've got two different unknown parts here, an X and a Y, which we'll deal with later. For now, let's put this in its proper way. So let's start with YB minus A, that's A to N, and insert that right there. So that would be O to P is therefore A plus X bracket YB minus A. And let's move this along as well to get this out of the way because we're going to need to work in that space. Let's expand that out. So we get A plus XYB minus XA. Okay, so all I've done is just expanded this bracket with those terms. So let's look at what we have so far. We've got one version of O to P in the blue and another version of O to P here in black. We now are going to, similarly like before, arrange them in such a way so that we can compare the coefficients of A and B. Obviously, this one's nicely ordered. We know what the coefficients are, but here we don't. Okay, so if we look at this one in a little bit more detail, let's put the a's together. Okay, so that will be an a here minus an x and an a there, and then the x, y, b right there. If you collect the like terms, so if you take out a, and then in here you'll have 1 minus x. So when they multiply out with the a, both of them will still give you that. And then for this one, we'll just have x, y, and a b. So now let's compare the coefficients. So remember this was O to P. So if you look at the value of a, the coefficient of a, it's going to mean that 1 minus x is equal to 3 over 10. And xy is going to be equal to 3 over 10 as well. So let's write that down. So 1 minus x is equal to 3 over 10, and xy is equal to 3 over 10. So this is the coefficients of a equated, and this is the coefficients of b equated. Now, first one, very straightforward. We are going to take this onto this side and the minus x onto this side, making it positive. So it's going to look like this. 1 minus 3 over 10 is equal to x. 1 minus 3 over 10 is 7 over 10. So x is equal to 7 over 10. And for this one, now that we know what x is, we can plug in here 7 over 10. So therefore, sub x 7 over 10. In fact, we don't need the bracket. Let's get rid of that. So 7 over 10y is equal to 3 over 10. Now, we need to have y on its own. So we are going to multiply by 10 onto this side and then divide by the 7. So if we multiply that, we get y on its own. So 3 times 10 is 30 over 10. And then now we're going to divide by 7. Okay, we're going to divide that by 7. In fact, let's do it in steps. Let's not try to be a hero and make a mistake. So 7y would be left, and then 30 over 10. So I've just multiplied by the 10 over here. And now I've got 30 over 10, which is 3. So 7y is equal to 3. And then y would be now equal to 3 over 7. So I've got x is equal to 7 over 10, y is equal to 3 over 7. Let's go back up and see what they were both referring to. So x here, let's get rid of it. Let's not get rid of it, but let's write. X was, what was it? 7 over 10. And y was 3, oops, not 3, 3 over 7, yes. 3 over 7. We are trying to work out the ratio O to n and then n to b. If you look at this, this is 3 parts out of the total of what? Of 7 parts. So that means n to b would have to make up the full 7 over 7. So that means n to b would be 4 over 7. And now we have the ratio O to n, n to b is in the ratio 3 over 7 dot dot 4 over 7. But in simplest form, it's just 3 to 4. And that is your final answer. Hope you enjoyed this video. Please give it a thumbs up and keep sharing it with your friends and your family so that it can benefit many youngsters as they go through the ranks of GCSE and onto the A level. Thank you for watching and see you in the next video.